So in this video we're going to look at vertical translations of toolbox functions. And the main idea here is that if we have a real number k that's greater than 0, so a non-negative real number, and we have a toolbox function given by f, that if we create a new function g from f by adding k to it, the graph of g will just be the graph of f shifted up k units, or if we build a new a new function g from f by subtracting k from it, then the graph of g will just be the graph of f shifted down by k units. So I'm going to do this example on this slide in GeoGebra for you. That way I can use GeoGebra to do the graphing instead of my ugly freehand graphs. So in the first example, we're asked to build a new function g of x that we're to build from f of x by adding a 3 to it. And just like before, we want to look at the function f of x, and we want to identify who he is. So this guy is the toolbox function given by the square root of x. So we really want to memorize those toolbox functions and their shapes. So if g of x is built from f of x just by adding 3 to it, we take the original function f of x, which is just the square root of x, and we add 3 to it. And this is the new function g of x built from f of x by adding 3 to it. And again, we want to step in, find those nice lattice points on our toolbox function. This one is at 0, 0, this one is at 1, 1, this one is at 4 and 2. And then all we need to do is add to the outputs 3 units. So to the 0 we add 3, we get 0 plus 3 is 3. So we're going to get a new point at 0, 3. And to this one we're going to add 3 units to this output of 1, so 3 and 1 is 4. It's going to go up 4 units. It's going to go up 3 units to 4. So it's going to have the point 1, 4 on it. So it's 3 higher than the original output of 1. And this one's going to be 3 higher than 2, which is going to put it up at 5. So we get the input 4 corresponding to the output of 5. Notice that none of the input numbers have changed because nothing is happening to the input variable. He's being left alone, and the 3's are just being added to the function outputs f of x. And then again, you would hand draw as nicely as you could through those 3 points to get your new function g of x, which GeoGebra can draw much more nicely through those points than can I. So our other function we were asked to build was the function h of x, and h of x was to be built from f of x by subtracting 2 units from the outputs. So f of x is just the square root function, the square root of x, and we're subtracting 2, which in effect is just going to move the graph of the toolbox function down 2 units. So this point at 0, 0 will move down to 0, negative 2. This point that is at 1, 1 is going to move down 2 units to the point 1, negative 1. So again, this is just 1, the output 1. The output 1 minus 2 is negative 1. And here we're going to take the 2 and move that output of 2 down 2 units, or 2, an output of 2 minus 2 is now 0, so we get input 4, output 0, and you'd hand draw through those nice lattice points the transformed graph, translated vertically down 2 units, and of course GeoGebra could put the line through that much more nicely than I could. And again, so inefficiently I need to erase everything on this example to do the last example. So the next PowerPoint slide that you have has a new example on it. We're supposed to translate a function up 2 units. Get rid of the rest of this garbage. So I don't think the application that I'm using I'm going to continue to use much longer. It's not an efficient way for me to do this, but it's going to do for now. Oops, except I was supposed to bring it up in GeoGebra. Here he is. Alright, so the next example said to take and build a new function g of x from the old function. And the new function is supposed to be the original function f of x with 2 added to the outputs. These are the outputs. We're adding 2 to the outputs. We'll look over here. We want to recognize the function family, or the toolbox function. This is f of x equals, this looks like the cubing function. So we're taking g of x and we're adding 2 to f of x, but f of x is just the cubing function. So the new function g of x is x cubed plus 2. Again, find your lattice points on the toolbox function. This one's at 0, 0. This one is at negative 1, 1. This one is at 1, 1. Those are 3 nice lattice points. And this plus 2 says add 2 to each of the outputs. Add 2 to this output, add 2 to this output, add 2 to this output, which will lift the function up 2 units. This will be the point 1, 3. The point here gets moved up to the point 0, 2. And this point here gets moved up 2 units to the point negative 1, 1. And then you would hand draw, and these are the ones I'm really bad at, the cubing functions. I was practicing before the videos, and that's when I finally decided, you know, I'm just going to do this in GeoGebra.